So number 4, you should notice that this is a perfect square and this is a perfect square. So that makes this a difference of squares. Okay? So you can treat this just like a difference of squares problem. So what's the square of 16x to the 4th? 4x squared. What's the square root of 81? 9. So you have 4x squared minus 9, 4x squared plus 9. Now here again, this is a perfect square and this is a perfect square. So what does that make this? Difference of squares. So the square root of 4x squared is 2x. Square root of 9 is 3. So you have 2x minus 3, 2x plus 3, and 4x squared plus 9. You cannot simplify a sum of squares, okay? There's no sum of squares. There's only difference of squares, all right? So for number 5, it asks us to factor. We have 4 terms. So what can we do when we have 4 terms? Grouping. Right. So I can take in 8x cubed out of the first term, and I'm left with x plus 1. Take out a 64. I'm left with x plus 1. All right, so from here, you would get 8x cubed plus 64 and x plus 1. So a lot of you guys, I think, would stop here, typically. But what is this here? Right, this is a sum of cubes, so we have to deal with that. So you'd get 2x plus 4, right? Because that cube root of 8x cubed is 2x. Cube root of 64 is 4. And then remember, it's a squared, so 4x squared, minus ab plus b squared, so plus 16, and then x plus 1. You could, from here, factor out a 4 from this middle section, so you could get 4, 2x plus 4, x squared minus 2x plus 4, x plus 1, but that's from here to here is not something I would take off points for. From here to here, I would most definitely take off points for. Okay? So 6 asks you to find all real number solutions. So the first thing you're going to want to do is get them all on one side. So x to the 5th plus 3x to the 4th minus 8x squared minus 24x equals 0. So now before I do anything else, what do all 4 of these terms have in common? X. So I can pull out an x, and you get x to the 4th plus 3x to the 3rd minus 8x minus 24. So once we're here, we would factor by grouping. So you get x. Out of here, we can take out an x cubed. So we get x plus 3. Out of here, we can take out a negative 8. We're left with x plus 3 equals 0. So now I'm just going to rewrite this again. X cubed minus 8, x plus 3 equals 0. Now this here is a difference of cubes, but since we're not factoring completely, we're simply just solving, you don't have to carry out that operation. So we can just set each of these equal to 0. So you get x equals 0, x equals 2, and x equals negative 3. So we need to divide. So when we're doing this polynomial division, you first have to make sure that it is in standard form. Both of these are in standard form, so we can continue. So we have 4x squared plus 2x minus 1 going into 2x cubed minus 4x squared plus 3x plus 5. All right? So I have 3 terms here. So that means I'm going to look at 3 terms here. So I'm taking these 3 terms, putting them into these 3. And remember, our objective with this is to somehow get from this term and match this term. So how can I turn 4x squared into 2x cubed? Multiply by 1/2 x. Good. So we multiply by 1/2 x, and then we get 2x cubed minus x minus 1/2 x. Yeah, this should be x squared, sorry. Plus. So now we just carry out the subtraction. These are going to cancel. Negative 4 minus x is negative 5x. 3 is 6 halves, so 6 halves plus 1 half is plus 7 halves plus 5. So again, I have 3 terms and 3 terms, and I want to somehow get from 4x squared to negative 5x squared. And what would I have to multiply to do that? Negative 5 fourths, yeah. Negative 5 fourths. So then you'd get negative 5x squared minus 10 fourths, which is minus 5 halves x, plus 5 fourths. And you're subtracting that. So now these would cancel. 7 halves minus negative 5 halves is 12 halves, which is 6x. 20 fourths minus 5 fourths is 15 fourths. So that's your remainder. So your final answer would be 1 half x minus 5 fourths plus 6x plus 15 fourths over 4x squared plus 2x minus 1. Okay, so number 9 asks you to factor and find the zeros, I believe. Anytime they give you a 0, okay, and they ask you to factor and solve, chances are you're going to be doing synthetic division, okay? So they tell you 6 is a solution. So I'm going to use that. 6, and I have 5, negative 27, negative 17, negative 6. Make sure that that is in standard form. So then we carry out our synthetic, and it works, okay? So remember, if 6 is a 0, I write that as x minus 6, and then I have 5x squared plus 3x plus 1 equals 0. And it wants me to solve for my remaining zeros. This is not going to factor, so what I have to do is quadratic formula, okay? So your zeros are going to be x equals 6, and then you're going to get negative b, so negative 3, plus or minus the square root of b squared, 9, minus 4ac, so that's going to be negative 11 over 10. So remember, when we get a negative under a square root, what do we do? Right, just take out an I. Right. So those would be your 3 solutions. But you could also write this second part, as I did on the answer key, as 6, negative 3 over 10, plus or minus I root 11 over 10. So I personally like this one better, but like I said, I'll give you credit for either one. Number 11, all you had to do was list the possible rational zeros. So remember, that's when we're doing P over Q, where P is our factors of the constant term, Q is the factors of the leading coefficient. So I have 8 and 3, so what I do is I just list out the factors of my constant term, so plus or minus 8, plus or minus 4, plus or minus 2, and plus or minus 1. And then I put them over the factors of my leading coefficient. So that would be plus or minus 1 and plus or minus 3. So it's just plus or minus 8 over 1, plus or minus 8 over 3, plus or minus 4 over 1, plus or minus 4 over 3, plus or minus 2 over 1, plus or minus 2 over 3, plus or minus 1 over 1, plus or minus 1 over 3. And those would be the possible rational zeros. And you're done. Alright, so for 12, it asks you to use the rational zero theorem to solve for the zeros. So, again, I have 7. The only factors of 7 are 7 and 1, and negative 7 and negative 1. So we have plus or minus 7 and plus or minus 1. So I'm just going to try negative 7 at first because I think it's the answer. So bring down the 1, negative 7, negative 5, 35, 1, negative 7, 0. So it is, okay? So that tells me that negative 7 is one of my solutions. So I have x plus 7, and then x squared minus 5x plus 1 equals 0. And again here, this does not factor. So you have to do the quadratic formula. So we get x equals negative 7, and then negative b plus or minus the square root of b squared minus 4ac, which ends up being 21, all over 2. And again, you could write this as 5 halves plus or minus root 21 over 2. So either one of those would be correct. Alright, so 13 wants you to write the least degree polynomial with a leading coefficient of 3 given these zeros. Now don't be tricked, okay? You're only given 3 zeros. That doesn't mean you only have 3 zeros. What if you have, anytime you have an I, what do you have to have? A minus I. So that means that 3 minus 4i also has to be a 0. Okay? And does this specify what kind of form it needs to be in? No. So if it doesn't specify, I'm putting in an intercept every single time, because that's the easiest form to put it in. So leading coefficient 3, you just put a 3 out front. X minus 0, x minus 3. And then for this, just make sure you do it nice and neat. So x minus 3 plus 4i, and x minus 3 minus 4i. And you can just leave it like that. Okay, this asks you to find if negative 5i is a solution. So you could just do direct substitution, plug it in. What I did is synthetic substitution and just looked and see if my remainder was 0. Remember, for this, you have to put this in standard form. So I have no cube term, so I have to have a 0. And I have no x term, so I have to have a 0 there. Alright? And then from there, you would just go ahead and solve. So bring down the 2, negative 10i, negative 10i. Negative 10i times negative 5i. Negative 5 times negative 10 is 50, times I squared, which is negative 1, is going to be negative 50. Alright, so multiply these, you get negative 40i, negative 40i. Negative 40 times negative 5 is 200. I squared is negative 1, so negative 200. You get 0, so that proves that it is a solution.